Hello, welcome back to my channel. Today I'll be going over how to solve for enthalpy in chemical reactions. So what enthalpy is, it's basically the measurement of heat, whether it's being absorbed or released. So whenever you solve for chemical reactions, when it comes to change of heat, it's either positive or negative, and there's either an endothermic reaction or an exothermic reaction. So the difference between those is that an endothermic reaction absorbs heat. Think of endo as an enter. Heat is entering the system, therefore the heat change is positive. And then exothermic reaction, I like to think of it as exo, exit. So the heat is being released or exits out of the system, and your enthalpy is negative. And the formula for this of enthalpy in a chemical reaction is your enthalpy of your products minus your enthalpy of reactants. So I'm going to jump ahead with this first example here, where you have this double replacement or single replacement reaction, and then you have these values here of these singular enthalpies, and you're solved for the sum of the enthalpy of this reaction. So again, it'll be products minus reactants. So I'm going to start off with the products. As we all know, the products are on the right side, the reactants are on the left side. So to break it down, my product side have these two values here, negative 113, and then we have negative 269. So NF3 is negative 113. And by the way, this is already balanced, as you can see, and there's only one of NF3, so it's just negative 113. And then you're going to add your negative 269. However, there's three of them, so I like to add this parentheses here so we do the math correctly. So it's negative 269 times 3. So when we solve for this slowly, so negative 113 plus negative 269 times 3 is negative 807. So when we do our final sum for this, negative 113 plus negative 807, you get negative 920. That is my product side. My reactant side, I have my negative 46.2 and I have 0. So my NH3 is negative 46.2, and we're going to add, but again, this is 0. Not that it's nothing, it still matters in the reactions, but it doesn't really affect our reactant side. So it's 0 times 3, but 0 times 3 is 0. So my reactant side is still negative 46.2. So I have my products value and my reactants value. So my delta H, my delta enthalpy, will be by negative 920 minus negative 46.2. So I have to be really extra careful, especially when you're subtracting a negative. So you should know by now that when you subtract a negative, that turns into a positive. So when you do this, when you solve for this, you end up with negative 873.8, and the units for enthalpy is kilojoules per mole. That is the change of enthalpy of this particular reaction, and since this enthalpy is negative, this is considered an exothermic reaction since it's releasing heat. Alright, so for this next example, I'm going to have you try this by yourself. You have this simple synthesis reaction, and you have the singular enthalpy values for each component. So I would like you to solve for your product side, your reactant side, and have your full solving. So pause this video, solve it on your own, and then play it to check your work. So this is a pretty simple solving problem, because we love to see zeros because it's less math to do. But as you can see here, we have a value for the product side. We have 90 for nitrogen monoxide, but then there's two of them, so 90 times 2 equals 180. And my reactant side is just 0. And when we solve for our change of enthalpy, it's just 180 minus 0, which is still 180 kilojoules per mole. And I also like to add a positive sign so we know that it is absorbing heat. It is an endothermic reaction. So this concludes my tutorial on enthalpy reactions. Pretty simple and straightforward. I hope this video helped, and thank you for watching.